Welcome to the short subject relating to process measurement, in particular use and maintenance, and the sub-subject of shop calibration. The calibration is an important aspect in most professional industries, in that it is used to verify that the system is actually recording a process that needs to be monitored. Now, there are several specific steps in calibration, and the first is actually to make sure that the instrument that you're using to measure a parameter is within specification, and firstly that has to be tested against a known reference. It then has to be altered if it is outside that particular point, and then re-verified to make sure that it is within calibration once again. So that step process can either be conducted out in the field or out of the field in a laboratory or in a shop. So depending upon the criticality of the system, the requirement of the level of verification and calibration, it becomes an important aspect to take it out of service or out of field. Now, there's one important aspect, and one general rule is that the only relatively low accuracy verifications can be done out in the shop floor for higher level and for critical systems, and ones that generally require mandatory points. You need to take them back to the out of field and then back to a laboratory or a shop that will able to do the system. Now, the fact that you're taking it out of service, then you must be able to put a regular timing aspect to that. It can't just be ad hoc, it has to be a certain point. So it has to be at regular intervals, and depending upon the criticality of the system and its environmental conditions such as vibration, heat, temperature, and pressure, humidity, it may require more frequent verification steps and verification checks, but a yearly subject or yearly period is one that is common. So there are different, as I said, different aspects. One is the bench or a shop calibration. It is generally done to a higher specification level, mainly because the instruments of which it's comparing against tend not to be portable. They, the higher the accuracies are, they tend to be a lot more sensitive, and it generally takes a lot more time to actually do it, because it has to be physically disconnected, placed in a suitable container, then transported to the part of the shop or the bench, and then calibrated against the higher accuracy level. Now, in field calibration, it tends to be a little bit less scrutiny, and usually tested to a wider tolerance level, mainly because you may not have the ability to check it against a very high standard instrument. Field calibration is one of the most common used ones, mainly in non-critical systems, non-critical instruments, and often ones used in process control, because to remove them and to actually take the whole point out of service becomes an onerous part. So it does save a lot of time to do in-field calibration, but you're compromising the actual the standards generally. Okay. Now, a typical lab that is required, it comes in many different forms. So you, as I mentioned earlier, all the parameters are compared against a standard, or what is referred to as a reference. And the reference can either be, depending upon the nature of the instrument, against an electrical signal or against a physical signal. And there are two ways to calibrate that, depending upon the criticality, again, of the system. So if you have say for instance a pressure transducer, and you wish to make sure that the 4 to 20 milliamp is actually against a 4 to 20 milliamp excitation, then you begin comparing electrical to electrical parameters, with basically ignoring the physical transducer, where you wish to test the whole instrument from the physical transducer right to the electrical element, then you could use something that simulates the known environment, such as a dead weight, such as an actual calibrated and very accurate pumping system, so that there are various ways that labs are set up, and they usually compare the unit under test to a very closely guarded and defined reference standard, and they are able to produce the documentation that is often required for checking of the various systems, including when it was last checked, the conditions under which it was verified, the results under which it was verified, and also traceability of the standard back to its standard as well. So just as a instrument out in the field has to be checked against a standard, the standard itself also has to be checked against a higher accuracy standard, and that could either be through a national standard, through an international standard, but it needs to be that traceability. So it's important that the higher standards that you are required, you need to have a stricter control, mainly because the level of variability really comes down to vibration, by humidity levels, by temperature levels, by pressure levels, all of which could affect the reading of a particular instrument. And you may have in the lab the ability to adjust the instruments to make sure that they are compliant. As I mentioned before, you either check against the electrical properties or against the physical properties, so simulation such as temperature bath, pressure points, force gauges, electrical parameters such as the volt and amp are all used as simulation, and they're usually non-portable equipment, but the equipment within the lab tends to be the minimum standard of which you need when the compliance is to a mandatory standard, in other words, to a safety standard or even to a regulatory production standard as well. Thank you.